Hi everyone, welcome to my channel, Student Ibrahim. Motion in a straight line. Today we are going to discuss about motion in a straight line. That is, what are the points are there inside we need to discuss. That is introduction, distance, displacement, speed, instant speed, average speed, and velocity, instantaneous velocity and average velocity, acceleration, instantaneous acceleration, and average acceleration. These are the points. So, what is motion in a straight line? Motion in a straight line. So, what exactly it is? So, normally, if you take, so I'm taking the car. So, car is moving in the part like this. So, you can take the car is moving on the road in a particular direction in a straight line. Okay. So we'll talk. So initial velocity of the body will be there, final velocity of the body will be there. So it is moving certain distance with certain time. Okay, with this all the quantities we consider. So the body is moving in a single path. Okay, so along the x-axis we can consider. That is considered as motion in a straight line. So bird is moving, or car is moving, or lorry is moving. Or if you take a ball and hit the ball, then the ball will move in a particular direction or along the x-axis to the move. Then we can consider the body is in a straight line. Body is moving one directional path, one direction path, either this direction or it is moving backward direction, whatever it may be, it's moving one path in one direction. So this is considered as motion in a straight line. So there are so many examples are there. So we can take this one. Okay, fine. So now, what is the distance? Distance is nothing but, here you can see this is point A. I'm considering the point A. This is the point A I'm considering, and this is the point B. Okay. So I want to move from point A to point B. I can move like this. So in between point A to point B, there are so many points will be there. So many points. I'm connecting all the points because I'm traveling in this way. So I'm traveling in this path. Okay. So I'm connecting all the points. The line joining of all successive points or the length of the path. So this is a length we can consider. This in this path I choose it. So I'm traveling in this path, or you can travel in this path, the length of the path. So what is this length of the path? Or if you can travel like this, or you can travel like this, or any direction you can take, or in this path you can take. Okay, the total length of the path, the total length of the path, length of the path, path is called distance. The total length traveled by the body is called its path. The total length of the path, simply we can consider the total length of the path is called distance. Clear? Okay. So a body is traveled 2 meter. So you can take north, south, east and west. East direction 2 meters, south direction 4 meters, again east direction 6 meters, like this. What is the total length of the path? So you can simply add all the points. So here you can take A, B, C, D. So then we can add all these points like 2 plus 4 plus 6 then we can take 12 meters. The total length of the path is called, we can consider 12 meters. Okay, so I'm taking magnitude. So here I'm considering only magnitude. So magnitude means some quantity. Okay, the quantity which can be measurable, that is called physical quantity. Here I'm considering only magnitude. Okay, so that is about we can consider distance. I hope you got it. Next one, displacement. So the displacement. So here I'm taking the same point, I'm considering the same 2 points. Okay, or you can take, this is home and this is school or college. School or college. College I'm taking. So generally from home to school I can travel like this. I can also travel like this. I can also travel like this. I can also travel like this. There are many paths are there, but from this is the initial point I can consider. This is the final point you can take. The shortest path from initial to final, so it has particular direction also, that is called displacement. The shortest path, so I can say the shortest path from initial point to final point, final, or you can take initial position to, not only point, you can consider initial position to final position, initial position to final position. Final position is called displacement. I hope you got to know clearly. So once again you can listen carefully. So what is displacement means? The shortest path from initial position to final position is called displacement. Now simply you can see here. So there are many paths are there. So here there are many paths. So this is A, B, C, D, like this if you take, but it is the shortest path. X is the shortest path. Okay, the shortest path from initial position to final position is called displacement. Okay, so a body travel. So one example we will take, a body is travel. So I'm taking north, south, east and west as well. So body travel in each direction 6 meter. After that it travel 4 meters towards west direction. Find out the displacement. Then how you have to take? You have to take the shortest path. So which one is the shortest path? This is the shortest path. So I'm considering this x. So from Pythagoras theorem you can take x square equal to 6 square plus 4 square. X square equal to, so 36 plus 16. Then we can take x square equal to how much? 40, 52. Then x equal to root over 52 meters. So that is the answer. Like this we can solve, we can get to know, we can identify the displacement of the body. Clear? Right. Next one, speed. So what is speed? So normally if you take speed is nothing but the distance traveled by the body per unit time. Simply we can consider distance by time taken. Distance traveled by the distance, a body covers the distance traveled by the body per unit time. You can consider the distance. Simply we can take the distance traveled by the body per unit time, per unit time is called speed. Is called speed. This is the first point. Coming to second point, it is a scalar quantity. Scalar quantity. So what is scalar quantity? So the quantity which have only magnitude. Like if you take speed 2 meter per second, okay, it has only magnitude. So we are not mentioning in a particular direction. So body is moving like this. So we are not mentioning the body is moving towards east, the body is moving towards west. We are not mentioning the particular direction. Simply we are saying the body is moving with the 2 meter per second. So it has only magnitude, like 2 meter, like mass you take 4 kg, like that. So we are talking about only magnitude. So the body is moving with some 2 meter per second. So then it is called scalar quantity. Third point, SI unit of speed equal to meter per second. So SI unit of distance is meter, SI unit of time is second anyway. So SI unit of speed is meter per second. So we can take this one, right? And so we can take the dimension formula. Dimension formula is, so meter means length. So anyway, mass 0, L power 1, T power minus 1. So this is a dimension formula. So here you can take meter, that is length, and time. So if you go down, it will go up. So then we'll get L T power minus 1. Then anyway, mass is not there. So M power 0. So we know X power 0, Y power 0, Z power 0, all the values equal to 1 only. Because so 1 power 0 also 1 only. We can take like this. So any value, any variable you can take, power 0 is equal to 1. So that is about speed. Instantaneous speed means speed at particular instant. So train is moving on track at the particular instant. What is the speed? That is called instantaneous speed. At that instant, at that particular time, what is the speed of the body means? That is called instantaneous speed. And if you take a watch, or clock at certain time, so at that particular second, what is the time? So that we can take instant. So at that particular time, what is the body speed? Then that is called instantaneous speed at that particular time. Average speed. So average speed means total distance by total time taken. Average speed is nothing but total distance by total distance by total time taken. Total time taken. So remaining all are same only. Meter per second, M per 0, L per 1, T per minus 1, all are same. SI unit is same, and emission formula also same, right? So this is about speed. And coming to the velocity. So velocity is nothing but, if you are taking velocity is nothing but displacement by time taken. So in a previous so I already explained displacement. So displacement has particular direction along with the magnitude. So we can consider velocity is nothing but the displacement traveled by the body per unit time. So you can consider simply displacement by time taken. Displacement by time taken. What is the SI unit of velocity? Velocity SI unit is meter per second. So you can take meter per second symbol. And second point you can consider. Second point. And third point is dimension formula M power 0, L power 1, T power minus 1 as speed dimension formula we can consider. But here the difference between speed and velocity is only direction. So everything same, but only the direction is different. That is the reason we are talking about velocity, and that is speed. Clear? Then now instantaneous velocity. What is instantaneous velocity? Velocity at particular instant. So the body is moving in a particular direction So suppose north and south, east and west. He is moving in east direction with certain speed at a certain velocity meter per second. So 2 meter per second you can take. Okay. So velocity of the body at particular instant. So the only difference is the direction. The difference between speed and velocity is only direction. So remaining everything is same. Next one, average velocity. So what is the average velocity? The average velocity is nothing but the net displacement or the resultant displacement by time taken. Resultant displacement by time taken. So V bar direction will be showing S bar by T. The resultant. So that is only difference. Rest of the things are same. The net resultant displacement by time taken or net displacement by time taken. Resultant displacement we can consider displacement by time, total time taken. You can consider total time taken. Clear? So these are the points. Velocity means displacement by time taken. The displacement covered by the body per unit time. So meter per second. So anyway, direction is the thing. M power 0, L power 1, T power minus 1. And here we can consider. So body is moving in a particular instant. At that particular instant, what is the velocity of the body? That is called instantaneous velocity. Then average velocity means the resultant displacement by total time taken. That is called average velocity. So clear? I hope you got it. Next one, we can go for acceleration. So what is acceleration? Acceleration means, so normally if you consider acceleration, so A bar equal to, so nothing but direction V bar by U bar. V bar by U bar by T. So this, normally if the body is moving on level road, so initially the body velocity is U. After the certain distance, after certain time, the final velocity of the body is V. So the acceleration of the body is final velocity minus initial velocity by time taken. What is the acceleration? Sorry, acceleration we are discussing, right? Acceleration is nothing but final velocity minus initial velocity by time taken. That is acceleration. So SI unit if you take, already velocity is meter per second, again by second, so we'll get meter per second square. If you write meter second power minus 2. Whereas dimension formula, if you consider dimension formula, so then that will come m power 0, L power 1, T power minus 2, because time is square, right? So anyway meter is length, so m power 0 mass is not there. So I'm considering m power 0, L power 1, T power minus 2. That's great. Now, so we'll discuss about instantaneous acceleration. What is the instantaneous acceleration? Acceleration at that particular instant, everything you see, either speed, velocity, acceleration, you only know instantaneous. That's only one term that's common in all the points. That is instantaneous acceleration. Instantaneous acceleration. Instantaneous means at that particular point, at that particular instant, at that particular situation. What is speed of the body? Instantaneous speed. What is the acceleration velocity of the body? Instantaneous velocity. At that particular instant, what is the acceleration of the body? That is instantaneous acceleration. Great. Now, average acceleration. What is average acceleration? Average acceleration is nothing but, simply we can say, the change of velocity. the change of velocity by time taken. So how much ever change within the body, the total change that we can take. So that is A equal to V bar minus U bar by T only we can consider average acceleration. The total change in the velocity, that is called average acceleration. Clear? So remaining everything is same. Then that is about today's topic. Thank you so much for listening. I hope so you understood very well about the topic. Thank you so much for listening. So please do like. So if you like, I feel very happy. Yes. So then I will do more videos. Then you can share your friends to share the knowledge and subscribe for more videos. Thank you so much. Your STB, the student, the brand.